Today in class we talked about real numbers and putting those in our graphic organizer. What we're going to talk about tonight are square and cube roots. So on your table of contents, if you'll add that, square and cube roots. And we're also going to start a squares chart, which we're going to use tremendously in this first unit. And then later on when we get to Pythagorean theorem, we're going to use that as well. So here's our graphic organizer from today. You picked up a paper that says square and cube roots. So I'm going to go ahead and fill mine out, and then you can do it as I do it and then put it in your journal. So square root has this symbol right here. This is actually called a radical. We know it's a square root because it doesn't have a 2 here. If there was a number, for example, down here, there's a 3, so this is going to be a cubed root, and that is different than a square root. A square root is our standard notation, so you'll never see a 2 here. You just need to know that it's a cube root or a square root. So what this is saying is here you have a box, and you can see that this is a 4 by 4 box, so there are 16 boxes in here. So what this is saying is what number times itself is 16? So if you look down here, 4 squared is 16, 4 times 4. So the square root of 16 is 4. So squares in square roots are inverse. So we can say a square root is any number that shows the area of a square. A square as in the shape of a square, but also to square a number or times it by itself. The square root is the side length. So the square root of 16 is 4 because each side of this square is 4. Okay? And we're going to make a chart in a few minutes to show this relationship. So here we have a square. This is 9. There are 9 squares in here. So we can say the square root of 9. Well, what times itself is 9? Well, what are the side lengths of this square? The square root of 9 is 3. Here I have 4 squares. So the square root of 4, what are the side lengths? 2, because 2 times 2 is 4. Here I only have 1. The square root of 1, well, what times itself is 1, or how big are the side lengths on this square? 1. Now, these are three-dimensional, so that's a little bit different. This is going to get into volume, right? A square root was area. We're going to talk about this down here. This is called a cubed root. And a cubed root is any number that shows the volume of a cube. And we learned last year that volume has 3 dimensions. So we are saying here a number times itself, times itself, times itself. In this case is 8, right? Because I have 4, the side lengths are 2 by 2 by 2. So 2 times 2 times 2 is 8. Okay? So in this box right here, we have 8 cubes. So the cubed root of 8 is 2. And 2 cubed is 8. So the cubed root is going to be the side length. So instead of thinking something times something, now we have 3 somethings. So if you think back to when we did exponents in 6th grade, right? 2 to the 3rd power is 2 times 2 times 2. So here we have side length 3 times 3 times 3. Well, I know that 3 times 3 times 3 is 27. So I'm going to put my little 3 here. So the cube root of 27 is 3. I can also say 3 cubed is 27. Here I have side lengths of 1. So this is going to be 1 to the 3rd power, which is just 1. or I can say the cubed root of 1 is 1. So what we're going to do, I'm going to let you cut that out and stick that in your journal on your next page. You may not have enough space for this title, and you can just write that in if you like. But then the second thing I want you to do tonight is on your next page, I want you to make a squares chart. And again, we're going to come back to this when we get to Pythagorean theorem. So I'm going to take my page and I'm going to fold it in half. And then I'm going to fold it in half again. And this is going to give me some nice lines so I can write. Because we'll end up with 2 columns, or 4 total columns. So I'm going to draw my main column here. And then I'm going to have a column on this side. And eventually I'll have a column on this side. So what I want you to do is I want you to see the relationship between squaring a number and the square root. So here in this column, I'm going to write the square. And here I'm going to write the square root. And then if we have, this is going to be our overflow column, the square and the square root. So here I'm going to say 1 squared is 1. And the square root of 1 is 1. 2 squared is 2 times 2 is 4. So the square root of 4 is 2, because again, 2 times 2 is 4. I want you to realize that these are inverses. When we talked about solving equations last year, we talked about the inverse operation. A square and a square root are inverse operations. A cube and a cube root are inverse operations. Oh, my light went out. So what I want you to do is I would like you to fill this in. I just want you to go to 12. And I want you to continue the pattern we're doing. You should be able to do 12 without a calculator, no problem. And then tomorrow in class, we're going to check those and we're going to add to it. We're going to talk specifically about squares and square roots, and then we're going to extend that knowledge to exponents the next day.